Welcome to the second edition of the Biomedical Engineering Internship Day. The reason we are organizing this event is that we want you to be sure that you're picking up the topic that more interests you when you're doing the internship. So since there are courses that you do before and then after, maybe this event may help you to choose better, and also for the exams that you are having later. And also this event is an orienteering event for the bachelor degree that have a chance to know what we do at the master degree level. Just a few words about the rules of the internship. You can enroll in the internship program when you are at the second year of the master degree. Of course, you have to have acquired the knowledge to do that. In general, the internship is 525 hours long. The hours are divided into internship hours, strictly internship hours that are 150 and 375 that are the hours for the thesis. Most of the students do a combined thing. They do the thesis in the topic in which they take the internship. However, it may happen that some of you have done an internship somewhere else or want to divide the two things. So there is also the option to separate them. From a formal point of view, you are supposed to be busy with the internship from 20 to 40 hours per week. That means that you have to consider at least 13, 14 weeks for your internship. That is about 4 months at least. So be aware of that when you plan, for example, the graduation date and so on. You have to identify an academic tutor that usually is a professor inside the biomedical engineering degree. The academic tutor, and then a company tutor. The company tutor can be a person from the business company if you are taking an internship out of our university, or it can be another professor if you are taking an academic internship like the ones proposed today. And the company in that case is the department. Of course, these rules are hold for the master internship, not for the bachelor one. Today, you will see that there are several presenters, several professors that will present their topics. They are all professors of the master degree. However, since there are also bachelor professors of the bachelor degree that have some advanced topic on which they do research and that would like to propose as for an internship topic, from time to time you will see also some presentation of the bachelor professor that teach in the bachelor degree, hosted by the professors of the master degree. So since I'm also a professor in the master degree, I start with my presentation. I used to teach the course of biomedical signal and data processing. I'm saying I used to because from next year the course will become biomedical signal and image processing. So that means that the topics for the internship that I'm offering are on biomedical signal and images. The students will perform the internship in the cardiovascular bioengineering lab or in the bioengineering lab. There are 2 labs that I manage. You see some pictures of the lab and of the activity that we do there in the figure here, and many of our activities can be found in this website, that is the website of Brain, brain.de.univpm.it with the E of brain written as a 3. There you can find a lot of information that today, of course, I need to be short. And in the lab, I'm supported by Agnese Sbrollini and Ilaria Marcantoni, that are who are two research fellows, then Sofia Romagnoli, who is a PhD student, and Chiara Leoni. As I said, I propose internships mainly in the signal processing and image processing. In particular, for the signal processing, as you know, there are 4 phases, stages in the signal processing: the acquisition, the transformation, the feature selection, and the classification. Our internship main focuses on the last three stages: transformation, in which we can find the best filter, for example, for cleaning the data. The very interesting part about the feature selection, in which we identify, measure the feature that have a physiological meaning, because remember, in bioengineering, you always have to have a feature with the biomedical, with the physiological, clinical meaning, and then the classification, in which we decide if a signal belongs to a healthy or a diseased person. And to do that, we can use either the traditional statistical approach or artificial intelligence. Same thing, or analogous thing, can be said for the image processing, in which we recognize the formation, the enhancement, the visualization, analysis, and management, with several steps within each stage. And we will focus mainly on the enhancement and the analysis and the further classification. Now, let me present the projects in which you will be able to collaborate. The first one is about sport. This is a project that we do in collaboration with other professors of our university, in particular to Professor Brocchini and Professor Morettini, but also in collaboration with the Division of Pediatric Cardiac Surgery of Ospedali Riuniti di Ancona, Foro Italico University in Rome, and Politecnico of Turin. This is a project in which we mainly using the wearable and portable devices, we try to monitor the biomedical signal of athletes, not only to measure the performance as is normally done, but also for monitoring his or her health status, in order to avoid health problems, and to fight sport-related sudden cardiac death. That is a dramatic event that from time to time, for example, we see on TV for famous athletes, but that may happen to everybody. Is more common than what is expected. The second project that we propose is a project on perinatal monitoring. That means that we are looking at the baby in a period that is close to the delivery. So we have the prenatal monitoring, which is done in collaboration with the Department of Obstetrics and Gynecology of Ospedali Riuniti di Ancona. That mainly consists in the computerized analysis of the cardiotocography, that at the moment is still performed visually by the clinicians, and of course that results in some subjectivity in the diagnosis. And then we have the premature baby monitoring, that is in collaboration with the Department of Neonatology, also of Ospedali Riuniti of Ancona, and is the monitoring of a premature baby that, of course, as being premature, may have several health problems and needs to be monitored constantly, in very special condition, maybe to give alarms if something goes wrong, no? If he stops breathing, or if he or she has cardiac problems, and so on. The third project is a project with from a regional project in collaboration with Namirial and with the Division of Pediatric Cardiac Surgery of Ospedale Riuniti di Ancona. Is baby telemonitoring, in which we want to develop some tools to monitor baby at home instead of that in the hospital after surgery. The third project is the first aid project. Is a project in which we use deep learning for early medical diagnosis that can be applied to signals, so to the ECG or to PCG or other signals, but also to images, and in particular to pulmonary scan and brain MRIs. These are this project involves, as I said, artificial intelligence, as the name says, and is in collaboration with Professor Aldo Franco Dragoni from the informatics group of UniVPM. We also have other collaborations with Professor Mara Fabri and Professor Gabriele Polonara about neuroscience and research activity in brain imaging, but at this point I give the word to Mara Fabri that will present the project herself. So Mara, if you are connected.
Okay, good morning. Can you hear me?
Yes, yes.
I do not leave the camera off. Okay. So good morning, my name is Mara Fabri and I work with Gabriele Polonara since a long time in imaging research, in brain imaging research, basically in two fields. The main activity is cortical activation and brain mapping, and the study to also study the interhemispheric connectivity. And sometimes we also are involved in applied research, we can say, in pre-surgery evaluation of important area of the brain before surgical to the neurosurgery. Next slide, please, Laura. Okay, these are two examples of the first kind of research, the first topic, and we studied brain activation, in particular cortical activation evoked by touch stimulation. To do this, we applied the touch stimuli according to a block design and stimulation protocol, as shown here, to the left hand. And we analyzed, localized the activation in the contralateral hemisphere and also in the ipsilateral hemisphere by studying the BOLD response, which means blood oxygen level dependent. We found in the cortex in both hemispheres and in the white matter of the corpus callosum. This was a rather new results, which we published many years ago. And this region is the same, which is crossed by fibers connected to cortical areas activated by sensory stimulation, which can be evidenced by diffusion tensor imaging tractography. Also we can do with our software. For brain imaging, we use this mainly Brain Voyager, and for this we are a naive stage. We use the Funk tool, which is a custom General Electric software, but we can aim strongly to improve this analysis. Also, we studied activation by visual stimuli, and in this way, we propose to administer the visual stimuli to the right or left visual field through Google's compatible with MRI environment. And we can see here the activation in the right hemisphere when the stimulus was in the left hemisphere, sorry, when the stimulus was in the right visual field. Also in this case, other than activation in the cortical gray matter, we found activation in the white matter of the corpus callosum in a region crossed by interhemispheric fibers connecting the two visual areas. The next goal we would like very much to obtain is to visualize these two kind of analysis of images, so bold response and DTI fibers in the same image. We hope to, with your help, to reach this goal. Then the next slide instead thank you, shows example of the pre-surgery evaluation, in which we see a patient with a tumor in the frontal region. And we, in this case, try to evidence the cortical area devoted to the control of contralateral hand movement. And we see here that the activation evoked by simple hand movement is rather far from the lesion. So the surgeon is rather sure to can operate without affect these regions. Or often it is requested to localize the language here areas. In this case, the patient has a tumor here, which could be extended frontally and posteriorly, anteriorly and posteriorly. And we evaluated by test language, which could be or auditory stimuli or visual stimuli, the activation of language areas in the left hemisphere. This is in particular is Broca area in the frontal cortex, which is far away from the lesion at the portion of the brain. And that's all for now.
Okay. So once again, most of our research projects can be found in brain. So now I conclude and leave the word to the next presenter, that will be Professor Sandro Fioretti. If
yes, thank you, Laura.
yes,
And
yes,
now
can you see?
To share the screen, if possible.
Yeah. Okay, you can go.
Yes, I'm trying. Okay, I suppose we are. Condividi. Do you see? Do you see?
Not yet.
Now?
No.
No? I don't know why.
Maybe we can.
Perhaps you can go to the next.
Oh, okay. We go to.
I have to do something in authorization. I don't know what.
Yes. Let's go on with the Professor Alessandro Mengarelli, yes, and then we will come back to you. Okay.
Yes. Thanks.
Okay. Alessandro, is Alessandro present?
Yes.
Okay. Try to share the screen.
Okay, I'll try.
Okay.
You can see.
Yes, yes.
Okay. Okay. So I can. I'm Alessandro Mengarelli, and for this year I will hold the course of dynamical modeling of movement. In this brief presentation, I'll show you 7 possibilities for project and internship. 3 are related to the, in general, to the analysis of balance in both healthy and pathological subjects. The other 4 projects are related to the topic of the hand gesture and, in general, motion recognition by a myoelectric pattern approach. So the first project deals with regards the identification of different diseases from balance data, from posturographic data. Posturographic analysis or balance task is a simple clinical task, but one can obtain a huge amount of information from this simple task. And the idea is to put together all of this information, such as granuration forces, time course of center of pressure, torques, and so on. The idea is to fuse all this information and to investigate the most useful and reliable indexes or features or signal processing techniques, the most suitable indicators or features able to provide an identification between a different kind of disease. And also the idea is also to try to investigate if from this data we are able to distinguish in between the different states of the disease. The value is given that an identification of a disease from a simple clinical task as the balance, as the the standing posture task is quite useful because it is a very simple clinical task. Another project is also in this case, also this project focuses on the computer-aided identification of, in this case, neurodegenerative diseases from, in this case, gait analysis data. In particular, this project aims to investigate the temporal development of the stride time duration during a gait analysis task. This represents a quite less considered time series in literature, but it has been it was in literature. It was shown that this kind of time series has encompasses a very complex information, and thus the aim of this project is to investigate this kind of time series in order to provide, in this case, an identification based on a simple, also in this case, a simple clinical task as a gait analysis task, an identification of neurodegenerative diseases. For instance, this data in this case are relative to patients affected by Parkinson's disease, amyotrophic lateral sclerosis, and Huntington disease. The last project related to the analysis of balance or gait is, in this case, this project aims to investigate the time course of the center of pressure, in this case, which one can record from a posture standing analysis through nonlinear techniques, which are quite different with respect to the classical analysis performed on this kind of data. And the aim is, in this case, is to unveil the dynamics, the control dynamics made by the central nervous system enacted to maintain balance, which is a very complex task, despite it can appear quite simple because it involves a series of requires a fine control and, more importantly, a continuous control of the central nervous system. So the aim is to use nonlinear techniques to investigate the inner dynamics in this kind of time series, which can reflect the control dynamics and properties of the central nervous system. So coming to the projects related to the myoelectric pattern recognition, the first project focuses on the aim of this project is to integrate the information coming from inertial sensors to boost the performances of the in the classification of different gestures of the hand or in general of the upper limb. So the aim is to integrate to the classical electromyographic signal used for gesture or movement classification. The idea is to integrate the inertial information to this kind of data, and in order to also boost the performances of in recognizing a wide range of hand or upper limb movement, and also to investigate the possibility to identify and to correctly classify fine movement of the hand, for instance, of the fingers. Another project in this project also it is also related to the molecular pattern recognition, but in this case to the motion intention detection. This means that the goal is to recognize a movement before the movement is fully deployed. So a kind of predictive, if you want, identification of a movement. In this case, there are some aspects that make this application quite challenging. For instance, in this case, the window taken into account, the window of the SEMG signal used for, in this case, is quite short, and within this window, you commonly have a transient signal, which requires quite different techniques for both signal processing and feature extraction and selection. And so the aim is to investigate in particular this aspect, and in particular in this case it would be taken into account the shoulder movements. Another project regards the development of multi-user myoelectric interfaces. So, which is the problem? In this case, the problem to be investigated with this project regards the fact that a learning model or a classifier classically works very well for a single subject in this kind of applications. So the classifiers and the learning models for myoelectric-based motion recognition are highly subject dependent. This means that if they are trained on one subject and then tested on the same subjects, work very well, but if they are applied to a different subject, their classification performances will encounter a dramatic drop. And so the aim is to investigate both signal processing technique to pre-process the EMG signal, and then feature extraction, and in particular techniques related to the fusion of features from different subjects in order to obtain more general learning models to be applied to a wider number of subjects. So avoiding the need for a training of this model for each single subject taken into account. The last project is also related to the use of electromyographic signals, but in this case the aim is not the classification of movements, but in this case the aim is to the reconstruction of kinematic quantities from this kind of data. So starting from the EMG signal, the aim is to have an estimation of the joint, of the movement of the joint for both the upper and the lower limb. So starting from the EMG signal, this project aims to investigate the most useful, on one hand, the most useful features for obtaining a robust regression of the joint movement, But also this project aims to investigate the most suitable regression models to obtain the angle reconstruction, because in general there are various approaches proposed in literature, and so also in this case the project aims to investigate both the aspect related to the feature extraction and also the aspect related to the learning models in order to obtain a reliable joint kinematic motion estimation, and in particular on the upper limb joints, which presents a high degree of freedom as the wrist joint. So in conclusion...
Yes, I have to ask you to conclude, because we are already late.
Okay, I have to say that all this project will be developed at the Movement Analysis Laboratory, and for more info you can check the BRAIN website.
Okay, thank you very much.
Thank you. I'm sorry for the delay.
Thank you very much. Let's see if Professor Fioretti is ready.
I hope yes. Now we try.
I have to ask in the meantime to try to be on time, on your time, as not just you, but all the presenters that will follow, to stay in the 10 minutes. Let's see.
I am not able to. I don't know why I have put the privacy information. I had enabled the Zoom to share the screen, but I don't know now why. If sorry for this, but I had prepared a very general presentation, that because I was sure that Alessandro Mengarelli would be taken a very detailed and in-depth relation about some of the arguments that we do in the Movement Analysis Laboratory, the new Movement Analysis Laboratory, where the students, the master students that wish to do thesis in the movement analysis context, devoted mainly to rehabilitation aspects, but not only, also for sport or for leisure activities, could develop their thesis. And some of the arguments that were cited by Alessandro Mengarelli very in depth are also part of my relation. What I would like to stress out is the fact that our group, that is constituted by me, of course, but also by Professor Federica Verdini, Professor Mengarelli, and Dr. Tigrini, that is a postdoc, was mainly devoted to the description of human motion capture and characterization, and in particular, as we have seen, for to study the control of human posture, and also on the modality on which some motor tasks like gait, sit to stand, functional reach, or other kind of tests that are usually used in rehabilitation context are performed. Now the attention has been given to also to electromyographic recording in order to study, to realize, to have some information about the anticipation of motion intention detection, for the reason that Alessandro has shown. Last argument that I would like to say, because it is very new, and it is very recent, the acquisition of instrumentation, is for to study the effect of immersive virtual reality on equilibrium maintenance by means of ad hoc protocols that have to be studied in collaboration, of course, with our partners, our collaborators, physician collaborators, in particular, the rehabilitation department of University of Ancona. This is all. I apologize for not being able to share the screen with the Zoom, but this is the situation.
I think Federica is trying at least to give a brief view of the presentation. So let's see if she just connected. Let's see if she can share the screen. Okay, so maybe she can say also, maybe Sandro, you can, on the second slide, Federica, you can say a few words about the lab, because I know that is one of the most beautiful labs in Italy about the movement analysis. So this is the view of the lab. Maybe you can add a couple of words on this.
Yes, I can add a couple of words, but I have to say also that Federica Verdini, Alessandro Mengarelli, and Andrea Tigrini live in the lab, really live in the lab from 8 in the morning until 8 in the evening, and so they are perfectly able to show the lab. In any case, the lab is at our department, at the Department of Information Engineering, at the first floor. It is completely new and is constituted by, you see here, an 8 camera infrared cameras for 3D data acquisition by means of reflective markers put on the subject. As a person that have followed the courses that I teach at the bachelor and at the master course, no, we have 6 dynamometric platform covering as a whole, as one platform, a walk path of 240 by 80 centimeters, and also a barographic, in order it is able to measure pressure distribution under the foot platform, a wireless system of EMG that does not need wires to connect sensors placed on muscles and on the skin, of course, over the muscles. And we are dealing with surface electromyography, of course. We cannot do needle electromyography, that is a neurology activity. Is with 16 electrodes, and also an inertial sensor system. What is our trend is to develop methods mainly that now allows to exit from the laboratory in order to monitor and to be applied in ambulatory and also at home of the patients, or in another context where, for example, sports can be done. For example, we have studied Tamberi rehabilitation during his before the last Olympiads, and they came at our laboratory in order to perform to monitor the status of his motor performance, just to say an example. So it is, we are not interested only in rehabilitation, but also for any other activity where motor activity is performed. Thank you, Laura, for this.
Thank you very much. You know, when you are online, that might happen. Okay, let's move to the next presenter. That would be Professor Michela Morettini. So let's see if she can share the screen.
Okay.
Oh.
Can you see my screen?
Yes.
Okay. Sorry. Okay. Good morning, everyone. I'm going to introduce topics for the internship and thesis under the course of Models and Control Biological System that I teach this year. All the activities will be performed at the Bioengineering Lab in the endocrine metabolic area and will be supervised by me in collaboration with Professor Burattini, and will be assisted by Dr. Agnese Piersanti, who is a PhD student at our university, and will be done also in collaboration with several partners, national and international partners, from the technical point of view, but also by the clinical point of view, such as the Medical University of Vienna. I cannot, sorry, I cannot, okay, yes. All the activities will be related to the study of glucose metabolism. When we refer to glucose metabolism, we usually refer to the fact that normally insulin and glucagon work together to maintain normal glucose concentration. And when something goes wrong, there is diabetes onset. Diabetes, there are several kinds of diabetes. The main one are diabetes, type 1 diabetes and type 2 diabetes. But there is also gestational diabetes mellitus and other kind of diabetes. When we study glucose metabolism, we cannot refer just to insulin and glucagon, but we have to refer to a plethora of phenomena that determine glucose metabolism and that should be accounted for and characterized. So what can we do as bioengineer? We can, of course, provide devices and methodologies to monitor such processes in everyday life condition and facilitate the management of the disease. But on the other side, we can provide methodology to quantitatively study such processes. And in most cases, such processes cannot be directly measured. And on the other side, we can also provide methodology to quantify such processes in the clinical setting, because when we refer to the clinical setting, we have to take into account issues concerning the time and the cost of the clinical examination that we are asking for. So in these kind of studies, the methodological approaches that we can use are many. The main one, of course, is the approach related to system modeling. In this case, the main kind of system modeling that we are using are the pharmacokinetic and pharmacodynamic models. We can create pharmacokinetic, pharmacodynamic model to simulate process, but we can also create models to estimate parameters on the single subject and on a population level. In this case, we refer to population models. In this case, parameters of the model will account for differences in the population characteristics, such as, for example, age, gender, body mass index, and whatever. On the other side, we can refer also to data-driven models, such as, for example, machine learning models, neural networks, and other kind of data-driven models, using different kind of data. Of course, we can use data coming from the usual clinical test. We can use data coming from electronic health records, but the main focus on this kind of approach is looking carefully at the data, because when we want to study this kind of system from a biomedical point of view, we have to be sure that our conclusions are good because the data are good. The question that normally the student do is which kind of programming language or software? Of course, we can use different kind of software and programming languages in relation to the purpose that we have. If we want to develop, for example, a simulation model, we can use MATLAB, of course. But if we want to use a population modeling approach, we have to use more dedicated software, such as, for example, Monolix. If we want to go in the direction of a data-driven model, we can use software and programming language more devoted to this kind of approach, such as, for example, Orange, R, and some other software. However, what I always say, this shouldn't be the final aim, okay? The software and the programming language should be chosen on the basis of the aim that we want to reach. Going to the macro topic that we are studying right now, of course, there is the continuous and flash glucose monitoring, which is an approach in which we can have real-time data to facilitate the management of the disease or to monitoring glucose in everyday life condition. This kind of devices overcome the limitation of the traditional set monitoring of blood glucose made to finger pricks that every one of us knows. There are different kind of devices, of CGM devices, such as, for example, the real-time CGM, which monitor constantly glucose and provide alarms to the patients, but there are also other kind of devices in which the user have the same information but required to consciously scan the sensor in order to obtain glucose data. Which are the open issues that we are dealing with in this kind of topic? Of course, this kind of devices, CGM device, provides a large number of glucose readings that should be interpreted. And there is still no consensus on the way by which this should be interpreted and on the metrics used to interpret the data. So part of our activities are devoted to understand how to interpret this kind of data. Why the data produced by these devices are useful? These kind of data are not useful just to type 1 or type 2 diabetes, but in a near future will be devoted to monitoring also the general population. So this will be an important step in order to prevent the development of the disease. And on the other side, this kind of data are useful to provide approaches of personalized medicine, because normally the subject, diabetic, type 1, type 2, or other intermediate categories are classified on the basis of clinical criteria. But looking at the data that we have from the continuous glucose monitoring, we can also classify subjects on the basis of glycemic variability, which will be another important characteristics in clusterizing patients. Another kind of topic that on which we are performing studies is insulin clearance characterization. Insulin clearance is one of the phenomena that regulate insulin concentration in the blood and is an important pathophysiological mechanism in type 2 diabetes. Insulin clearance is a process that that takes place in the liver and in the kidneys and regulates level of circulating insulin concentration. Of course, this process cannot be directly measured because it would require very invasive procedure that cannot be performed in human beings. So we are developing approach to assessing insulin clearance and to characterize this process in different categories of subjects. The usefulness of these studies will be, of course, in subject who undergoes insulin therapies, because understanding how insulin is regulated in the blood is important to calibrate insulin therapy. And on the other side, the study of this process provides, help us to gain insight into pathogenesis of type 2 diabetes. Last but not least, I would like to introduce this third topic, which deals with characterization of beneficial effect of exercise on metabolism, in which we are creating models to model how the organs communicate each other to develop this beneficial effect of exercise on metabolism. These studies are under the idea that we cannot talk anymore of metabolism, but we have to talk about immunometabolism, in which metabolic and immune phenomena cooperate to exert beneficial effect, exercise beneficial effect on metabolism. We have developed a model describing the crosstalk between the muscle and the adipose tissue, for example, but we are developing also a model to describe the crosstalk between skeletal muscle and gut, for example, and see how these affect insulin secretion. So this was a very brief presentation. More information, as Professor Burattini said before, can be found in this website, webpage of the Brain Group. So I hope that I respected the time. Not sure about it.
Okay.
Okay.
Thank you very much, Professor Morettini. And now is the turn of Professor Lorenzo Palma. If stop sharing the screen.
Yes, I'm trying to do it. Oh, okay. Oh, I cannot.
Let me see. Maybe you can try.
Try to share my screen.
And see.
Yes,
if
I
it
cannot
processes.
open the window. Okay.
Okay.
Okay. Okay. Good morning, everyone, and thank you to the Professor Burattini for the opportunity to show you all the possible thesis internship opportunity regarding all the course of the biomedical engineering course. I briefly introduce myself. My name is Lorenzo Palma, and I am the professor of the Internet of Medical Team course for this year. Internet of Medical Team course provide you all the basic in order to approach the possible internship that I will show you in the next slide. And in particular, Internet of Medical Things focuses on the connected object, their architecture, their design, and how they can be used for monitoring the health of the patients. Talking about Internet of Medical Things, as you know, nowadays we have more and more, or better, more care are delivered outside the hospital, and this trend has been further accelerated due to the pandemic that has been affected us during the last 2 years. And forced many people to seek remote treatment or diagnosis without the access to the hospital. Internet of Things in general, Internet of Things technology play a critical role in improving healthcare for individuals and also for the communities. By providing new and more efficient way of accessing communication and storing information, Internet of Things can help bridge the information divides between health professional and the community they serve, and between the development of wearable sensors, databases, communication infrastructure, and network, and the practitioner who need it. Moreover, near the Internet of Things, we have the information and communication technologies that provides the capacity to improve health system efficiencies and prevents medical error. Keep in mind all of these aspects. Internet, and here we have a briefly introduction, briefly example of the technology of which we will study the network connection to store information in the cloud, and the development of machine or deep learning approach to support the diagnosis and monitoring of patients. Regarding the possible internship arguments, we can see the indoor and navigation localization, in particularly based on Bluetooth technology. We can work on EEG or ECG signal, and this is a possible internship developed in collaboration with the Professor Burattini Research Group, in particular with the focus on the working monitoring. We can work on performance analysis of arthritis, and we can work on glucose monitoring. Among the possible collaboration with other research group, with other institute and with company, we can develop a smartphone application for the home monitoring of patients. This in particular with Santo Stefano Rehabilitation and Ospedale Riuniti Marche Nord. We can work on monitoring of vital signal in hostile environment, and this can do in collaboration with the Diverse Alert Network. We can work on stress monitoring at work in collaboration with Professor Burattini, as I said before, and the FATER group, that is a partner of a big project in which our research group are involved with. We can work on diverse monitoring, also in this case in collaboration with the Diverse Alert Network and Marche region. We can work on Parkinson patients monitoring in collaboration with Santo Stefano, and in sensors for monitoring type 1 diabetes in pediatric patients through the development of machine learning and deep learning algorithm in collaboration not only with the Salesi Hospital here in Ancona, but in collaboration also with the other research group and the University of Verona and Napoli. Okay, summing up the possible internship argument, we can work on acquisition, processing, and the transmission of information in healthcare. We can work on wearable devices design and application, on communication architecture and protocol, for example, in the case of indoor localization. We can work on machine and deep learning algorithm development for healthcare, in particular for the application on frailty subjects like Alzheimer, multiple sclerosis, or Parkinson's disease patients, and pediatric patients. We can work on cloud platform development and management, and we can work on analysis of the acquired signal, also known as signal process. The most important knowledge that you must have in order to approach with success the internship and thesis argument are the knowledge of some language like C, like MATLAB, like Python, and so on. Of course, case by case, we can target the internship according to the knowledge of the students. As I said before, all the internship and thesis are available not only in collaboration with my research group, but also with other research group inside or outside the University of Ancona, and many of these arguments are involved in national and European or international very big project. Here we can see my research group that is composed by the key people represented by Paola Pierleoni and others important professors like Professor Turchetti. I have very good collaboration with Alberto Belli and Laura Faraschetti, and also in my teams there are many PhD students and research fellow. If you have any question and so on, you can write me on Teams looking for Lorenzo Palma, or write me an email. Thank you very much for your attention.
Okay, thank you. Thank you very much. So now we have finished with the first part of this event. There were 15 minutes scheduled for the break. Let's make only 5 minutes so we do not accumulate too much delay in our presentation. So let's stop for 5 minutes, and then we will continue with the second part of the event. registration. Okay, you can start.
Okay, here we are. I promise I will keep the schedule and will take no longer than 10 minutes, probably less. Can you see my slides now?
Yes. Yes.
Okay. Okay, so my presentation basically concerns the possible internships and theses related to the course I'm giving since a few years, which is entitled Biomedical Data Protection, and is in the first teaching semester. So it has just finished for this academic year. Basically, the motivation of the course and also the main motivation of possible internships and theses in this area is that biomedical engineering has to deal with biomedical data. Some examples of biomedical data are those you see here, for example, concerning examinations and monitoring, medical imaging, laboratory results, and so on and so forth. Nowadays, we produce biomedical data every day, even though wearable devices, any sort of biomedical sensor that is becoming widespread. However, we have to be concerned about security issues and privacy issues because the amount of biomedical data is continually growing. As you see here, according to some statistics, 30% of the world's data volume is generated by the healthcare industry, and it is continuously growing, about 36% per year, which is by far more than manufacturing, financial services, media, entertainment, and so on. And so this amount of data need to be protected. In Europe, we have the General Data Protection Regulation, which was introduced in 2016 and then enforced since 2018, which is a very important regulation with a new set of duties and rights for companies, institutions, and citizens concerning personal data protection of all European citizens. And among personal data, we have classical data like name, surname, address, localization, and so on and so forth. But we also have health information and biomedical data. So biomedical data fully lie under the GDPR provisions and probably are among the most important types of personal data we need to protect. And this is strictly related to cybersecurity because any threat to data protection is often related to cyber attacks. And there are a lot of cyber attacks against hospitals. These are some newspaper articles that are quite outdated, for example, coming from 2016. And more than 5 years ago, there were already attacks against hospitals. And looking at these titles, you may wonder that these kind of things mostly happen abroad. For example, in the US, these articles indeed mention American hospitals. But this is not the case, because, for example, in 2015, on our newspapers, they were speaking about attacks against Iesi Hospital, which is in the Marche region, a very small hospital. Despite these, attackers are connected through the internet, so any hospital is potentially exposed to cyber criminals today. And this may have serious consequences because, for example, here you see another piece of newspapers dating back to 2020 about the possible health consequences of a cyber attack. In this case, they were speaking about the death of a woman inside a hospital that apparently was partly due to a cyber attack. And this is because cyber attacks can affect healthcare systems like TC scan systems, patient data systems, and so on and so forth. Basically, we are following several lines of research in this area together with my colleagues. I also coordinate the local node of the National Cybersecurity Laboratory of the CINI Consortium, and we also cooperate with several companies. These are just 3 lines of research. We also follow other lines, but these 3 lines are, I believe, the most important we are working on related to biomedical engineering. So besides these, we also work, for example, on cryptography and on other technical subjects. But especially concerning biomedical engineering and data protection, we follow these 3 lines of research I would like to show you. The first one is a cyber risk assessment. Today, cyber risk assessment is necessary for any company or institution to comply with the GDPR. So this means basically measuring somehow the level of risk which an institution or company is exposed to in terms of cyber attacks. And you know, this is quite challenging because there are both deterministic and statistical models for cyber risk. There is a subjectivity somehow. So it is quite an open area of research, which we like to give some contribution within. The second line of research is blockchain technology, which is becoming more and more famous because of cryptocurrencies, Bitcoin, and so on and so forth. But blockchain is not only cryptocurrencies, it's an important technology for data certification, notarization, and interoperability. And there are plenty of applications of blockchain technology to the healthcare sector. So, for example, we are dealing with blockchain for healthcare, with privacy issues in blockchain, and other applications of blockchain technologies related to the healthcare. And the third one is biometric authentication. As you know, today we mitigate the use of mnemonic passwords by using biometric features like fingerprints, iris, and even electroencephalographic signals can be used for this purpose. And we are doing research for this because this is also related to data protection and cybersecurity as well. So these are the 3 main lines of research along which I would support internships and even master theses for biomedical engineering students. Coming to opportunities concerning internships, we can, myself and my group can tutor internship students both at the department and outside of the department. So we can organize internships on those 3 previous lines of research at the Department of Information Engineering here at the university, or in collaboration with healthcare institutions. Right this morning, I was speaking with some collaborators from Area Vasta 2, which is basically Ospedale di Uniti and other hospitals in the Ancona area, and also the regional agency for healthcare. And they are very much interested in hosting internship students at their institutions. Or we can organize internships with the companies. In particular, there's a recent startup company, Ancaria SRL, which is a spin-off of our university working in cybersecurity. Another company, which is called B-SRL, working in software and data management tools for healthcare facilities, and other companies with which we collaborate. Then, following the internship, we normally also offer a master thesis on these subjects with the possible outcome of a scientific publication. Here you can see 3 recent papers written by former students of biomedical engineering on the 3 lines of research I was mentioning before. That is cyber risk assessment, biometric authentication based on electroencephalogram signals, also in cooperation with Professor Scalise. The former one was in cooperation with Professor Chiara Luce. And the last one is about privacy in blockchain. We also have young collaborators, PhD students and postdocs that can follow and supervise, co-supervise internships and master theses. Okay, that's all. Thank you very much.
Thank you very much. Also to be in time. So now we can move to Professor Mandolini. Let's see.
Yes. Good morning, everyone.
Hear you. We still cannot see you on your screen.
Okay. Sorry for
Here
the sorry for the background. This is background of a virtual conference, so sorry about that. So I'm going to share to you my screen just in few seconds. So please let me know if you can see.
Yes, we can see.
Very good, very good. So thank you. Thank you for organizing this event. It's a great pleasure to me for meet you guys, dear students, and I hope to give you some information about internships and thesis proposal for this course, methods and tools for biomedical product design. And we'll also introduce you some topics for a colleague of mine, Professor Giacomo Palmieri. So basically today I would like to present you 4 research activities that I perform here in our labs and in cooperation with some colleagues of mine, PhD students and postdoc research fellows. So 4 main topics, and now I would like to give you some information about each of these research topics. So the first one concerns human modeling and numerical simulations. So basically, by employing numerical simulation software tools based on finite element analysis, we are going to analyze, for example, like you can see here on the top, the side effects of mandibular advancement devices, which are devices used in people suffering from obstructive sleep apnea syndrome. And by employing these software tools, we, for example, are able to see what's the displacement on teeth, what's the stress on ligaments, on periodontal ligaments, and additional kind of results. So we can give feedbacks to clinicians in order to adjust the design of this kind of devices. And for what concerns the second topic, we also use numerical simulation tools for evaluating, for example, the side effects of a misalignment of a knee prosthesis, as well as we use this software tool for designing new shapes for customized knee prosthesis for very specific patients. This topic is carried out in cooperation with Professor Alida Mazzoli from the Simao department, University of Padua, University of Brussels, and Ospedale Riuniti di Ancona. Well, the second topic concerns the application of augmented reality solutions for maxillofacial surgeries. So nowadays, typically such a kind of surgeries carried out by surgeons by using physical cutting guides. Here, the goal is to go beyond the state of the art, so use such a sort of head-mounted display that the surgeon can use during the surgeries in order to perform osteotomies as well as bone repositionings by watching the virtual holograms that the head-mounted display project here on the glasses. In this slide, you can see some pictures about the application developed so far. So you can see here on the right some a screenshot of the application, how the head-mounted display is used, and basically the hardware devices, software tools used for creating such a kind of application. This project is carried out in cooperation with, as before, Professor Mazzoli, and some maxillofacial surgeons. The third topic deals with additive manufacturing technologies. So here we would like to employ the unique benefits that these innovative production technologies may give in the design of custom-made insoles. So as you can see here on the right, using specific software tools like hand topology, ANSYS, and NetFab, we are able, for example, to design custom-made insoles with variable density, lightweight insoles, with the goal to reduce plantar pressure, reduce shear forces in order to avoid the birth of ulcers and additional problems in specific people like diabetic people. And this project is carried out in cooperation with a manufacturing company, a footwear manufacturing company here in Ancona, and the School of Design of the Loro University. The next topic deals with design and development of medical devices for supporting maxillofacial surgeries. You have seen before augmented reality. So in that topic, we were talking about something virtual. Here we're talking about something physical. So cooperating with some surgeons, for example, in the past, but we expect to do something also in the future, we developed, for example, devices like this one on the top right corner of the slide for positioning a preformed implant inside the orbital cavity in order to restore the correct shape of a damaged, fractured orbital cavity, as well as custom-made molds for shaping a standard implant directly during the surgery. Also, in this case, for achieving this goal, we commonly use computer-aided design software tools, 3D scanners, 3D printers, and so on and so forth. So here you can see some publications, some references where you can find out some additional information about the topics that I presented briefly right now. So here you can see my references, so my mobile phone, email address. So for any further information, please feel free to write me, but even feel free to come in my office. We can discuss a bit more in detail about what I have presented right now. I guess I should have additional 3 minutes, so I would like to spend a few words also for internship proposals and thesis proposals from Professor Giacomo Palmieri. He's professor working in robotics and biomechanics. Here you can find his email address. And for sure, Giacomo is available to explain you in much more details his research activities for internships. Basically, 2 are the topics. Here you can see 2 research topics. The first one deals with development of rehabilitation protocols for upper limb. You can see here on the right a video. So this is a collaborative robot that is used by a patient. So it's possible here to plan the rehabilitation protocol that the robot should perform according to that specific patient and that specific and his specific pathology. This activity is carried out in cooperation with the Neurohabilitation Clinic of Ospedali Riuniti Ancona. The next research activity deals with human-centered manufacturing. So here on the screen, you can see here on the right a short video This is a collaborative robot, so a robot that can work in the same environment where the technical operator works. So here it's possible to create an advanced working cell where technicians, people, and robots work together. It's very important for this topic study something about safety and ergonomics of operators. At last, here you can see a short video that shows you the HI Labs, the Industry Information Innovation Labs, which is located in Iesi. And this lab, as well as the Mechatronic and Industrial Robotics lab here in Ancona at the Department of Industrial Engineering, can be used for performing these activities. I hope you can see the audio. This is a short video, around 1 minute, and you can see here the facilities. This is the collaborative robot you have seen previously. Okay, I think that's a quick overview about also the Giacomo's research activities. So I think it's all from my side.
Okay, thank you very much.
Okay,
and now we can move to Professor Mazzoli, that was already mentioned in your presentation. Let's see, Valida is available.
Yes, good morning.
Good morning. We can see you.
Yeah,
and we can see your screen.
Okay. So I try to start the presentation. Okay. So we are able with our group. First of all, thank you, Laura. Sorry, I forgot for this opportunity. So as for regard the internships that we are able to offer the students. We try to involve students that follow the course of biomaterials and follow the courses in order to be able to design custom-made prostheses. So these are the two main topics in which the students can be involved if you decided to have an internship with us. When I talk about us, I talk about this team that it is composed, of course, by me and some colleagues of me. Professor Bellezza from the Department Simau and Professor Luzzi, again, from the Department Simau, and also Professor Mandolini that you have already known in the previous presentation. So in order to have an internship with us, of course, it is necessary that you are involved in these two courses. So the courses that it is biomaterials for medical devices and prostheses, that it is my course, and also the course of methods and tools for biomedical product design. So you are able to have the basis in order to develop your internship project. So we have diverse topics. So some of the topics have been already showed you by Professor Mandolini, and they are mainly dedicated to the design and manufacturing of custom-made prostheses that can be used in different sites of our body. We are especially focused in the maxillofacial area because we have found a good team of surgeons that are very interested in this kind of research activities, and that's why we have especially dedicated our efforts to the maxillofacial area. So in these figures, in these images, you can see, for example, the design and the manufacturing of a mold that can be used in order to reform a titanium net that can be used in order to restore the asymmetry of the eyes of this patient, as you can see here. Or again, a mold that can be used in order to treat specific kind of pathologies that can affect the face of the patient, such as in this case with a patient affected by the Apert syndrome. Or again, these techniques that are based on the usage of anatomical modeling and 3D printing can be used directly to manufacture a custom-made prosthesis that can be realized directly by the usage of biocompatible materials, such as, for example, titanium alloys, in order to restore specific anatomical sites that can be affected by some pathologies. As in this case, you can see this is a patient affected by a parietal osteoma that can be removed, and using the data coming from the mirroring surface, so the other portion of the skull, a custom-made prosthesis can be removed and inserted in the patient after the resection of the tumor. We have, in these activities, I am involved together with Professor Marco Mandolini, as he has also showed you, and these projects have been developed by some students that are involved in their internship and thesis project. Due to the fact that my course, it is specifically dedicated to the science and to the study of biomaterials, you can have also some projects that are specifically directed towards the biomaterials. So, for example, we can be able to characterize from a chemical and physical point of view specific kind of biomaterials that can be used in the body. In this case, you can see we have characterized some devices that are used in the orthodontic field in order to correct the malpositioning. And these devices can be affected by mechanical cracks and enzymes that are in the mouth that can affect these devices. And this can be studied by specific chemical and physical characterization techniques. Or, for example, together with Professor Scalise, we have developed some phantoms that can be used in order to be used with a specific kind of instrumentation. For example, in this case, these are phantoms that try to model the presence of a melanoma in the skin. And they have been used in order to evaluate the efficacy of an instrumentation able to detect these imperfections over the skin. Or again, using 3D printing techniques, you can be able to develop a specific kind of scaffolds that can be used in applications of bone tissue engineering, for example, in order to try to reconstruct a damaged bone tissue. And for example, trying to colonize these scaffolds by the use of specific kind of cells and try to evaluate the biocompatibility of and the osteo induction that can be exerted by this kind of scaffolds. You can be involved in the usage of different kinds of materials. For example, this is again a project that has been developed by one of your previous colleagues, in order to realize bone scaffolds in polycaprolactone, and also some studies using cells coming from rats can be done in order to evaluate the osteoconduction properties of this kind of scaffold. So in our laboratories, we have diverse kind of facilities. Now I have listed some of these for you. Of course, now it is not the time to describe all these facilities, but if you're interested in having an internship with us, feel free to contact me. Actually, I have forgotten to write down here my phone number, but you can find it on the UNISPN page. So now I can stop this. Okay, I can stop the sharing of the screen. So and I can give the control of the screen to my colleague, that it is Professor Bellezza, and he will show you some projects that can be done, dedicated especially in the fields of materials, such as, for example, polymeric materials, and some problems connected to the usage of metals. So Tiziano, if you want, you can start.
Could you see the presentation? Because yes. I have problems with double screen.
Yes.
No, it's okay.
It's okay?
Yes.
Okay. My colleague Alida Mazzoli showed before that there is the possibility to make a thermal characterization of polymers. So here I want to show you some characterization of materials involved in biomedical application. For example, here we have a PVC feeding tubes. PVC is typically a stiff material. So to be used for humans, you have to add plasticizer. The function of the plasticizer is to lower the glass transition temperature. And this parameter can be obtained by a differential scanning calorimetry, which was shown before in a photo in the presentation in the previous slide. If you add the plasticizer, you can obtain a more flexible material. It depends on the temperature. And so in this way, you have an object that can be used for humans. And on the other hand, you have the possibility to obtain specimen that can be tested by a tensile machine and determine the characteristic stress-strain curve, which is strictly related to the glass transition temperature. Because if we have materials working under the glass transition temperature, we have stiff materials, and in the case of this object, we have, with additional plasticizer, we need to have elastomeric-like material. Another possibility that I studied in the past is the corrosion, which is my expertise, my main expertise, corrosion of metallic materials. In particular, within the biomedical application, we can study corrosion of different metals or metallic alloy, like titanium alloys, or in this case, in this figure, I show you a case of a study of magnesium alloys in contact with a simulated body fluid solution. There is a particular specific electrochemical technique to assess the corrosion resistance of a given material in such kind of media. In this case, considering the high reactivity of magnesium alloy in aqueous solution, we have also the evolution of hydrogen, and we can also determine the volume of hydrogen. So using both information, corrosion resistance from electrochemical technique, and in this case, measuring the total volume of hydrogen developed by the corrosion reaction, we can assess the corrosion resistance of a given metal, and to know also the protective effect determined by the corrosion products which are formed during the corrosion process. So this is another possibility of experimentation regarding materials, metallic materials in biomedical application. Oh, I finished my presentation, and
thank you very much also for being with us today.
To be in time.
Okay, and now we can move to Professor Scalise. Yes,
I have to remove.
I can see him on the list, but still not. Okay, we can see your screen now. But we cannot hear you. Maybe I'm not sure that you're talking or not. No? Maybe he has some problems. So let's see if we can solve it quickly, or otherwise we can switch the presentation. Maybe we can ask while Professor Scalise solves his connection problems. Maybe we can ask to Professor Fattori if he is available to start, and then we will go back to Professor Scalise.
Yes, I am available.
Okay, let's let's start with you, and then we will go back to Lorenzo. Okay.
Okay.
You have a presentation?
Yeah, a short presentation on Tissue, that is my company, but I can begin only with my image.
Okay, as you wish.
Okay. Thank you for this opportunity. My name is Paolo Fattori. It's my first time in this kind of event. I'm a contract professor for the course on medical device certification and regulation, but I am also the CEO and co-founder of Tissue, that is a small company that produces medical devices for the regenerative medicine. It is based in San Marino Republic, and a startup that I founded at the end of 2020 in Turin that will produce medical devices for the heal of bacterial infections. I got a very short presentation on Tissue. Yeah, Vista. Can you see the presentation?
Not, we are still not yet.
I have to
share the screen.
I have to share the screen.
Yes.
Okay.
Yes, now we can see at least your screen.
Perfect. As I said, I founded Tissue in 2017. Then we have patented a process for the decellularization of heterologous tissues. So we have certified bone substitutes of equine origin, and we are able to decellularize the equine bone tissue to eliminate cells, lipids, and antigens. So the product in the end is biocompatible, and we have obtained at the beginning of 2021 the CE mark of this device. During the last 2 years, we have also certified other 3 families of medical devices for the regenerative medicine, a family of synthetic bone substitutes based on calcium hydroxyapatite, a family of collagen membranes that is produced from equine tendons, and a solution, an infiltrative solution based on bovine collagen peptides that is used for the heal of arthritis. We have a big facility, two production facilities in San Marino. One is smaller than the second, where we produce the 4 families of medical devices. And we have a huge biochemical laboratory where we have hosted in the past years students from UniVPM, from the University of Pesaro Urbino, and from the University of Pavia. And they have carried out internship in our laboratories, have graduated, and some of them have also published papers on indexed journals. These are our products that today are already on market. In 1 year, we have produced and implanted more than 40,000 pieces of products, so devices. And we have a lot of research and development projects, but we are searching for the second half of 2020. We offer an internship on developing a device for the treatment of implant surfaces to prevent surface contamination and post-surgical infections. This solution, this device will be based on a property technology that is a solution with a polymeric solution based on polyvinyl alcohol and polyvinyl pyrrolidone. And in this solution, we have also 3 main components that have an antimicrobial activity. We have the hydroxytyrosol, that is an antioxidant that is produced from olive leaves, and magnesium ascorbyl phosphate, that is the vitamin C that have a very, very high activity in prevent the interaction during the sterilization of the device of the gamma radiation. And also a bacteriocin, the nisin Z, that is a small peptide, but is able to open a pore on microbes. So with these 3 molecules, we are able to prevent the surface contamination of processes, for example. So we are searching a student that is able to make a strong research and development project to obtain a punch where we have to insert the processes before the implantation, and we have to treat the processes with our solution. And at this time, the project is at the beginning. We are certifying a gel for the periodontal disease, but we want to obtain the CE mark also for this kind of device. So if someone would like to apply for this internship, you can contact me. Maybe Professoressa Burattini can share my contacts. Thank you.
Okay, Thank you. I will for sure share your contacts to the students. And thank you also for this presentation from a company, no, which was a little bit different from all the other academic presentation, but it is precious, no, because we can have a very different internship, but as I will point out at the end of this event. In the meantime, I see that Lorenzo Scalli is connected. So thanks again, and we can move to Professor Scalise.
Thank you very much. Can you hear me?
Yes, now we can see you and hear you, and see your screen.
Yeah, you know, the Murphy law, everything was working till this morning, and then camera and mic was off. So sorry, and my apologizes for this shift between me and Professor Fattori. I was introducing myself. My course is Applied Measurement Technique. Is going to be in the first semester of the first year, and the aim of this presentation is going to introduce you to the possible internship that we can share with the students. Here you have a list of the possible area where we typically make research, so then typically have our internship topics available. Basically, we are a measurement group, so the issue is trying to measure, to have an objective quantization of the traditional direct and indirect quantities. We have many years, we say tens of years of experience on design and development of sensing system transducer. So sometimes we really design since the hardware and software in order to reach the scope of the measurement. Very large experience and very active at the moment is the testing of fluidodynamic and mechanic of cardiovascular system, in particular the biological prosthesis. This is done in collaboration with Ospedali Riuniti di Ancona, and so the surgeons that are using these prostheses. We have an explosion of activity in collaboration with some colleagues of our faculty on wearable technologies. There is a huge space of research in different fields. From some of these topics has been already introduced also by other colleagues. I remember, for example, Professor Palma, but also Professoressa Burattini, wearing the measurement systems allows you to measure during let's say outside the clinical environment and during real life, and particularly for stress, for remote monitoring, for evaluation of the physical and psychological status or of the user. This is extremely important. We take care about the quality of the data and the accuracy of these data and how to process them. So there is a lot of possible internship activity over there, which is very much connected to home monitoring and e-health. We have an interesting and growing activity on new design of medical device. In the next slides, we will see some of them. So we redesign or design a new medical device like ACG or prosthesis system. A lot of biomedical engineering for industrial application in terms of acoustic, indoor ergonomics activity is required. A new field which is, I think, very interesting is evaluation of sport devices. At the moment, we have a tennis racket, which has been sensorized, or well, we're trying to sensorize this in order to calculate some important parameters for the performance of the sportman. And we have a traditional huge activity and collaboration on neonatal intensive care devices. So mechanical ventilators, incubators, and other respiration monitoring system for these very, very young kind of patients. So just to give you an idea, here in this image, you have some of the application we have been we are walking around. There are this lady is sleeping on a mattress, which is indeed a system able to evaluate the pressure distribution and control the pressure that the mattress is applying to the skin of the subject in order to, as it is typically said, offload the pressure. We have special electrodes for ECG. We are designing this with a company, local company. So we have actually three patents on that. We have redesigning of this tibia sensorized system of fixture, and another very important activity is on diabetic foot offloading system. Here you have the things around the wearable. In particular, here we are aiming to measure the heart rate through the PPG signal, redesigning and taking into consideration the modifying inputs, which are really an issue in such a kind of application. This is done in collaboration with colleagues from Palermo University. These slides is just to give you an idea what we mean when we say neonatal intensive care unit. In particular, I would pose the attention on this device. This is a tube that is introduced on the patient to connect the patient to the mechanical ventilator. We are thinking to make some special nebulized release of surfactant. This is a regional project involving companies from Marche region and outside, and the neonatal intensive care unit of Salesi Hospital, very close to us. Around that, we also measure through laser, through thermocamera, the heart and respiration activity of the patient. The big activity on pressure is also focalized on shoes. Here there are some sport and fashion high-heel shoes, and two maps of the distribution of the pressure. For those that experience the wearing of high-heel shoes, it's very well known how painful they can be, and the reason is very clearly highlighted here by this high concentration of pressure on the front part of the feet. We want to measure this pressure distribution to have an idea on how high it is in order to go back to the redesign and optimization. So fashion elements together with mechanical aspects of the shoes in order to optimize, possibly optimize the results. Other wearable solution integrated with artificial intelligence. We have many collaboration with the Department of Information Engineering. With them, we have applied such a very promising approach with artificial intelligence to understand what is the status of the subject, if the comfort, thermal comfort of the subject is high enough in order to control, for example, the environmental situation around him. We have a nice and very promising activity on EMG and EEG. Professor Baldi introduced this collaboration. Now there is a PhD students that can develop this area. And electrodermal and non-invasive saturation PO2 measurement is also a possible topic for the internship. Going to the hand, there are some ambient assisted living projects. Ambient assisted living is an area of engineering where the attention is on the holders, so subjects with more than 65 years that living alone or far from caregivers. And here you have an example of some project on which the team is working, not me personally, but some member of my team. So social robots that can provide assistance to the user, interface and sensing by tablets in order to have an idea of the cognitive status of the subject, in order to reduce or at least to limitate the cognitive degree loss of efficiency of holders. A bit more industrial approach is the acoustic one through the Professoressa Milena Martarelli. So the human perception of sound in terms of materials, shape. The idea here is to use the biomedical and bioengineering information on perception of such noise and to use them in order to optimize the industrial product. Very interesting part is also the comfort, the thermal comfort of the environment. I just talked a few minutes ago about that. It's nice to see how the feeling of comfort, thermal comfort in a room is depending by some measurable parameters of the human being. So it's nice to have this contact point between the monitoring of the physiological condition of the subject and the perception of indirect parameter like the comfort. And so the problem of measuring comfort, which is a qualitative topic, but it can be also measured in some way. Going to the end, I'd like also to underline that there is the possibility to have Campus World and Erasmus-based internship. We have a strong contact with Mayo Clinics. Two of your colleagues are actually applying it in this moment there. We have strong and very fruitful collaboration with Greece, Western Asia University, German, Frey University of Wraxall, Marco Mandolini, Professor Mandolini already named it, and Twente University in Netherlands. Through this collaboration, we always try to have also scientific collaboration, and even with the other topics. I think it's very important to have the possibility from the master thesis to have already original, innovative results that can be of interest not only to the faculty, but also outside the faculty to the colleagues and researchers around the world. So most of the time we try to publish the results with the other. Don't want to take too much time. I think we were very much able to close in time. This is my contact point, but you can meet me around the corridors of the faculty or come to my office whenever you want. So thank you for your attention.
Thank you very much, Professor Scalese. So we are at the end of the event. I want to just thanks all the speakers, of the participants, the students that have been with us until this time. Just a short note, you have seen that there is a huge variety of internships that are offered. Some of them are, especially in the first part, are more bioengineering oriented. That means that you study the physiological systems. Some others are more industrially oriented, more company oriented. So for a few months, you will have the possibility of experimenting what means being a researcher rather than working in a company. And also you heard that there is the possibility of doing internship inside the companies or abroad, as Professor Scalese mentioned. So I think you can really find the the right internship for you. And the most important thing is that you have to enjoy to do the internship. It's not an exam that you have to do just because it's in the program, but it's something that you really have to enjoy while doing that. In the most academic internship, the goal is the product is a publication. So in many internship, you will be able to publish, maybe not in the time of your internship, because usually is a little bit longer, but with time your thesis may be published. Maybe in some other internship you will focus on a different product, that is the product of the company. So it really depends on what you're doing, but I hope you will appreciate the variety of internship that we are offering, and thank you for being until this time. It's lunchtime with us. For any question you can write to me. It will be a pleasure for me to forward the question to the other professor, or otherwise write directly to them. Anyway, feel free to contact all of us for question or for more details on the topics that we've mentioned. And we had to be really short, but if you want more detail, please contact us. So that's it. Thank you again, and thank you to everybody. And we can close.
Thank you very much.
Bye bye. Bye bye.